Thank you for joining us today in this meetup. I am Anjana Athanikar, Product Manager with OptraSCAN. Today with me, I have Mr. Abhi Golap and Dr. Aparna Joshi. Abhi is CEO and founder of OptraSCAN, the organization that is disrupting the digital pathology space. Abhi is an alumni of IIT Mumbai and Stanford University Graduate School of Business. He specializes in startups and product management. He has over 4 successful startups to his credits, and he's founder of OptraSCAN, as I mentioned before. He has invested in over 9 startups, and he has over 18 international patents. Along with Abhi, we also have Dr. Aparna Joshi. She is Medical Director of OptraSCAN. Dr. Joshi, she's a surgical pathologist with an experience of over 25 years at several prestigious institutes. She has worked on FDA clearance of automated immunohistochemistry image analysis for breast cancers and prostate cancer at Ohio State University, US. So this is just a bit in a nutshell about both their work. So today we will talk about the development of digital pathology and the transformation of laboratories using digital pathology. We will look at the past and, of course, today's theme, future-proofing your lab. Having said that, it's crucial to understand how to get your lab ready for digital pathologies. Basically the whys and hows, and how to navigate your way for successful deployment. So without further ado, I would like to ask Abhi to start his presentation. So yes, Abhi.
We will now get going with what we are presenting here about digital pathology and its future for the digital transformation of the laboratories. So before we start looking into how digital pathology is playing the crucial role, this is a scenario that many of us have already witnessed. A microscope, which is a very simple 150-year-old invention, is still being used as recent as even this year for the subjective diagnostics. It is also used for the second opinion peer review. And interestingly, we have witnessed over the last 2 to 3 decades the computers, cars, cell phones, radiology, everything got changed, but except microscopes. And it's very interesting to see that microscope, being a very simple device, is still a very crucial device for the oncology as well as infectious and inflammatory diseases. So the reason why people are looking at optical microscope transformation is to bring in more objectivity in this whole process, and also get rid of the huge stack of the slides, which are required to be maintained for at least 8 to 10 years because of the medical legal issues. And that is the precise reason why the glass slides now should be converted into digital images. Now, when we are looking at what are the options that are available in the market, some of you might have also already witnessed this, that the cost is presenting a significant hurdle in this digital transformation. Optical microscope, which was invented almost in 1800s, and then digital microscope, which was as recent as 30 years old invention. But then the whole slide imaging systems, which can bring in more objectivity at the same point of time, can be a fully automatic system, is very costly. And that is where you can see the market share by the digital pathology systems is still very low. The adoption is very low, mainly because the cost is a huge deterrent to many of us who are willing to actually go for digital transformation, but price just doesn't justify in the context of the return of investment. So with the help of our advisors, Dr. Abbas, who is the chairman of pathology at UCSF, Dr. Montine, chairman of pathology at Stanford, Dr. Gao, chairman of pathology at University of British Columbia, Dr. Morrow, chairman of pathology at Yale University, Dr. Wong, chairman of pathology at Duke University. OptraSCAN has tried to bring in an innovative solution, which is what is making a lot of sense in context of digital transformation. And that is where we have this solution, which is a complete solution, not only to digitize your slides, but also to help you review all those slides using a workflow application, then doing the analysis on the top of it. It could be breast cancer, it could be related to prostate, it could be cervical screening, and then sharing and interpreting that data. So Optra Telepathology, along with the experts who are available for the second opinion, plays an important role here. So this is a complete walkaway slide scanning and analysis solution, which has patents. And then to keep our cost of goods low, our whole solution is positioned in such a way that this can improve the diagnostics and research. This solution also has cloud enablement for easy data upload. But at the same point of time, you can see the type of digital scanning solutions that are available, which is one of that is called OS 15, where you can load up to 15 slides at a time, and it can scan those slides with a complete walkaway automation. And then you have an option for the continual loading of the slides without pausing the scanner. Some of the laboratories may have more than 15 slides, and that's where we have another model for 80 or 160 slides. And then for those laboratories where there are more number of slides required to be digitized, we have 320 to 480 slides scanning ability. This is a complete walkaway automation because you do not require any manual intervention here. And then this scans at 40x or equivalent of 40x in less than 60 seconds. So it can produce an image in an optical configuration of microscope at around 40x with 75,000 pixels per inch. And then this same image can be digitally zoomed up to 100x as well. As it scans, it has an option to store locally, or you can configure it to store it into the cloud. So this system can even sit on your administrative desk, where along with the documents, your administrative assistant can also scan the glass slides and then push it into the cloud or the local storage. The system has image quality assessment module that can keep a track of how good the image is getting generated for every glass slide. So you do not require any expertise or the human expertise to verify the quality of any slides that is being scanned inside the OptraSCAN system. OptraSCAN has a CE mark for the in vitro diagnostic use, and we are also ISO 13485 certified company. We offer two modes of scanning. One is a bright field and another is immunofluorescence. In addition to the scanning, this also offers some of the composite imaging abilities where you can see how the images are scanned and some of the areas which are not in focus because the cell stack has different focal planes. And we actually create an image called as a composite image where it picks up the pixels which are all in focus across the different Z levels. And instead of storing it as a Z stack, it can also store as a composite image. So with such kind of a patented technologies, our scanning solution becomes more efficient and more smarter when it comes to scanning the tissues or the cells. When we are trying to compare it side by side at one of our site, we did the comparison, and OptraSCAN not only offer the low price, but the best quality at low price. Because the optics that we are using is from Nikon, and that is why the optics quality, the imaging quality is of extreme importance when we are creating the slides and images associated to the slides. And that is where the image quality score is much higher compared to any of the products that are available in the market today. So before we start looking into how this whole infrastructure can be utilized for specific laboratories, I would like this slide to be presented to you where you can have OptraSCAN systems at various locations of your laboratories in a spoke and hub model. And then using those devices, you can connect those devices through the internet and to our slide management system. So all the data can be then pulled into our slide management system, where case structuring, integration with the HIS or LIS is there. You can view the images. You can also do the real-time teleconferencing with your fellow pathologist. Reporting is another such feature, and then the cloud storage offers an option for you to do it like either the local storage or on the cloud. And then we have image analysis abilities to analyze those slides. We have more than 55 customers who are now using our systems just in a span of 12 to 15 months. And then we are having the presence across the globe through our distribution network. OptraSCAN has patents, and we also have a CE clearance. And these patents help us to differentiate ourselves from the industry players. And then this helps us to not only keep the cost lower, but at the same point of time, many of our solutions have publications, which you will soon hear from our medical director about how our solutions are getting differentiated in the industry. So this is our distribution network. So all our customers across the globe are now able to get access to our devices through our global partners. And then wherever our customers are located, in most of the countries, we already have our presence. And that's how our systems are made available to our customers. Our systems are very easy to ship. They do not require any special installation procedures. They take it out from the box, connect it, and it starts working. It's really plug and play. And that is why the systems are very easy to use. Convert your slides into images, stores it, shares it, and analyzes it. So now I would request my colleague, Dr. Aparna Joshi, our medical director, to take forward and explain to you how this digital transformation for the pathology labs is feasible and possible.
Thank you, Abhi. There is an interesting picture that we see here, and it has summed up the entire process of the troubles that a pathologist has in one picture. Although it looks like a simple picture, there are so many activities which are happening and making my life easy. There is this man holding this glass slide. There's a tissue on that, some histopathology that we need to analyze. This glass slide goes into this fancy looking blue box. And then you just have to sit at your computer and view the screen. The screen shows up these glass slides, and you can actually view them at different magnifications. I will just take you to understand how we exactly do this. Not only do you view it, you store it, archive it, retrieve it whenever you want. And along with that, our solutions at OptraSCAN are able to analyze this with a click of a button. You're able to do morphological analysis, you're going to do immunohistochemistry, you're going to read some fluorescent slides. All these things can be done very easily because There are very good inbuilt software systems. And then once your job is done, you want to share your activity with other colleagues or make a report out of it, which is a standard format which is internationally accepted. All these activities can be done with the help of this OptraSCAN. And not only this, you're able to do it remotely and don't have to be inside the lab all the time. Can we have the next slide, please? Okay, so now I'm going to run you through how exactly do we do it. From the perspective of a pathologist, what we do is once you slide a glass slide under your microscope, you first screen it zigzag at a very fast speed, and then you locate the tissue where you have to go and actually look at the interesting part and analyze that area. Exactly the same activity is done inside this slide scanner. The first thing that happens is it reads the barcode and is able to identify what it is handling. Once the barcode is read, the slide goes and screens the entire, the scanner goes and screens the entire slide, and the area of interest is identified, just like a human brain does. The area of interest is then bounded in a box. Now, if you look at these three different slides, you will realize that each one, the design of the tissue on each one is different. One is completely fragmented and broken into small little pieces. And one is completely, it's the one on the extreme left is liquid-based cytology. And it is in a circular form with a single monolayer of cells maybe. And the one in the center is completely different from these two at the two extreme ends. Irrespective of whatever the layout of the tissue is, this scanner is able to identify the area of interest, and a bounding box or a play area is defined, and we will do most of our activities within this area. So not much time is spent in scanning area which doesn't have any material in it. No biological material needs to be ignored, just like the human brain does, and that will happen here. Next. After we have looked at it, we can let's consider this cytology slide. If you look at a pathologist looking at through a microscope, what you will see is the left hand of the person is moving the slide and the right hand is on the fine adjustment. All through my activity, as I move across the slide on a light microscope, my fine adjustment goes back and forth. With this patented technology that OptraSCAN has built in, we are able to do the functioning of the fine adjustment at one go, because all the cells stacked up in different layers have a precision of crisp identification, and they are all the surface of each and every cell, inclusive of the nucleus, is nicely displayed in only one plane. So although the refractive index of the cells remains different, the scanner is able to correct that refractive index and bring it into one plane. So the evenness of the entire slide is a highlight once you are seeing it on the screen. Now, if you look on this, there are different magnifications. If you look at this as a complete one single glass slide, you will see the circle of the liquid-based cytology at one extreme, and that would lead you like a map and would tell you where exactly which part of it are you observing. And at one end, if you see, there is a magnification index. So through that slider, your different levels of magnification can take you to the area of interest and let you look at the finer details at different magnifications. Next. So now let's go through the workflow of what exactly OptraSCAN offers. There is this image path which will take you through the workflow of our daily routine activities. And instead of going into the finer details and the technical details, I as a pathologist would be interested in actually running you through how one can function using this gadget. My day begins at, say, 9:30, and I have a whole tray of cases right on my desk. This is exactly what we are viewing now. These are assigned cases, by which we mean to say that the whole activity that I need to do of viewing slides and reporting and signing out is now displayed in front of me on this screen. I can choose to prioritize on this and decide what I would be interested in looking at first. And then I can change the sequence also. For example, if I get a call in the morning from a pathologist saying that there is an urgent requirement of speeding up a certain report, say a breast cancer one, then I would want to say, look at the slide number 15 and try to move it ahead and finish that activity first. So just by viewing at a glance, I'm able to prioritize my entire day and my entire activity. Next. Okay, so now I'm actually viewing this. As we go along, I actually want to bring to your notice that this whole activity, running the entire workflow of my histology setup, has actually worked the best through this pandemic. If you see, irrespective of wherever I'm sitting, whether I'm at my home desk or whether I'm at my desk in the hospital or wherever, I can function irrespective of the location where I'm placed. So during the pandemic, the real fact was that all consultants above 65 years of age had to be at home and could not attend hospital. This was the rule of the hospital for which I work. So our team is of only 3 histopathologists, and of which 1 histopathologist is more than 65 years of age. So in this situation, actually, this came handy, and we had all 3 of us working every single day, irrespective of everything. Other thing through this COVID pandemic was that the hospital was very conscious of saving their resources, in the sense that for 1 week, they would want 1 pathologist exposed to the hospital, the next week the other, and this is how they wanted. So while our physical absence was required, we still wanted to participate in each and every activity. And this is how we have been doing it all through. So now let's start looking at the cases. So this is my first case. It's a true cut breast biopsy. And I've looked at the H&E slide. I'm swifting through different magnifications. I have identified whatever I want to look at. And I want to do certain analytical things on this. Next. Yeah. So now we have a lot of algorithms and assays along with the scanner, and it helps you analyze the whole slide. Like in this picture, you're seeing I'm trying to overlay it with ER and PR IHC analysis. So in this ER analysis, what happens is, with the click of a button, a green and red overlay is laid on the blue and brown nuclei. And that is estimated accurately by the machine, and you get a score. You are looking at such kind of a solution because for human eyes, there could be either an error, or to avoid fatigue, one is tempted to do predominantly eyeballing, wherein the accuracy falls down. And all these things can actually be a deterrent. In addition to this, repeatability is the highlight of a machine. So there are certain activities which your computer will be doing better than your human brain, like a repeatability. If I look at this slide, if I score something once, I will score something else within a range of say 10%. I will have changes in my scores, because it's humanly not possible to be so consistent and repeat the activity. So the computer here, can you show me the next slide, please? Okay, so this analysis is going on, and the red and green overlay is now being laid on the nuclei of the breast cancer tumor cells. Next. Okay, so this is what I'm calling the overlay. So the green and the red cells are the blue and the brown cells which have been identified. If you watch closely, the lymphocytes have smartly been thrown out of counting, and then this algorithm is laying out a score in the region of interest. The whole functioning happens within the region of interest, and the computer, the solution is able to identify the region of breast cancer and function within that. Next. Okay, so this is a report generation facility which also is there. So with a click of a button, you are able to actually analyze these immunohistochemistry slides, and all you have to do is put in some fillers, and you have a standardized report system available here, and which can be shared immediately with any of your consultants, any of your doctors, any of your patients, or whoever you want to dispatch it to, and doesn't require much of an effort. Next. Okay, so we have a bunch of biomarker image analysis solutions available with OptraSCAN, and one of them is Ki-67. We have had several publications in various esteemed journals. One of this was in Nature. Ki-67, can you see a Ki-67 on the left side, where you have those blue and brown cells, the brown positive cells and the blue negative tumor cells. An overlay is put on these tumor cells with a green for negative and red for brown. This whole thing is analyzed and a score is given. Now, Ki-67 labeling index indicates how fast and how aggressively the tumor is multiplying. Not only does our solution give you this labeling index, which is just a score which tells you what is the percentage of fast multiplying cells and how much is the positivity of Ki-67. In addition to that, since we are using this system, we are also able to give complete information about what is the intensity of the brownness, how many of the cells are of a smaller size and how many of them are like a really big bizarre size, how many of them are spindle and how many of them are circular. Actually, we are here in an era where we want to have as much data as possible, which may make sense not today but tomorrow. We may want to use this data to come out with our own information, which may be of prognostic use or therapeutic use as we go along in managing patients. Next. Okay, so this another solution that is inbuilt is of morphometry. We were analyzing prostate cancer slides for a whole bunch of huge data, and we have come up with this solution for morphometry, which is actually able to Gleason a slide. So not only will it identify glands, but will be able to actually tell you whether you can draw a circle around the gland. Is it cribriform? Is it showing any secretions? Are there solid patterns? Are there monotonous patterns? Is there single cell infiltration? All these features are embedded in this morphometry, and it is able to come out with a complete Gleasoning score. So not only, this is an example that I'm giving you for prostate, because for Gleason, a lot of intelligence has to be built inside the image analysis solution, which is existing here. And this is an example. But in addition to that, we have other morphometry analytical solutions. Like we have one for the glomeruli, the size of the glomeruli, how many of them are sclerosed, or is there interstitial inflammation? All these features are embedded in another morphometry image analysis solution for the renal tissue. Similarly, we have for pancreas, wherein we're able to identify the islets of Langerhans, whether they are reduced in size, whether they are fibrotic, whether there is inflammation, whether there is chronic prostatitis, whether there is fibrosis. All these features are able to be identified through our morphometry tools. Next. Next. Okay, as we go along, there is one more publication which actually I can pride on. This is this publication came in Applied IHC and Morphology Journal, and this is PDL1 automatic scoring. So in immunohistochemistry, PDL1 immunohistochemistry is used for various cancers, and PDL1 is a as we know, it's a companion diagnostic for a drug, which is very costly and needs to be very accurately assessed whether you want to use the drug or not. So the oncologist is very much keen on understanding if you can give accuracy of your percentage of total tumor proportion score. Tumor proportion score is used in non-small cell lung cancers, and in that you have a formula by which you have number of PDL1 positive cells divided by a total of positive and negative cells, and then multiplied by 100 and find a percentage. And so this tumor proportion score, if it is less than 1%, it's not PDL1 positive. If it is between 1 and 49, then your score is showing PDL1 expression, and if it is more than 50, it is highly expressed. So based on this, our chemotherapeutic decisions and the immunotherapeutic decisions are made. Now in this situation, 1% or no, 6% or no, 49% or 52%, all these decisions can actually change a patient's life from the perspective of not only giving the drug, but also the financial aspect of it. Hence, one has to be really, really accurate. In this present picture, we are able to identify the tumor cells, the macrophages, the lymphocytes, the immune response, tumor cells which are negative, tumor cells which are positive, and come up with a score for PDL1. That is, this entire thing is done completely automatically with a click of a button. And our paper, if you go and have a look at it, has everything well explained in the publication. So this is, the next is immunofluorescence imaging. There are different structures that are identified by different color chromes, like astrocytes, microglia, blood vessel, etc., and a complete picture of 5-color composite segmentation and classification of all these brain cells are completely displayed in front of you. So this is one more solution that we have. Next. Yeah. Now, once you have analyzed, I'm ready with all the analysis and I want to talk to my peer. So within OptraSCAN, we have embedded a facility by which you can actually have remote consultation or telepathology. The remote consultation, like I told you, came handy for me in my COVID period. And telepathology is something you definitely want to have, not only for, especially when you're sitting on a frozen section and you want to really be sure of what you're handling. You would like to have another colleague have a peep into the microscope or whatever. But in such a situation, it is not always that they are by the side of a microscope or by the side of their desk. In such situations, telepathology comes really, really handy. Not only are you required to look at the screen on the computer, like the laptop or your iPad, etc. You can also use phones and have all these images viewing through telepathology and take consultations elsewhere. So peer review, remote consultation, telepathology has changed the lives of pathologists in a big way because the physical presence is not required. Participation can be at any time, anywhere. And the crispness of, like Abhi was just saying, the crispness of the images and the quality of the scans is so good that at times one feels that, you want to look at a particular area, you just go back and forth through the Zoom and you are really satisfied with the visual impact. So that is an added advantage. Next. Yeah. So histopathology, yeah, we are used to looking at peer reviews and all that. But the highlight here is cytology. The OptraSCAN prides on the fact that its cytology solutions are really very, very attractive and changing lives of pathologists. We have cytology. This is a pap smear. You have different magnifications as you see. And within the system, we have embedded a cervical cytology Bethesda classification for cervical and vaginal cytology. Now, how does this function is very interesting. I'm going to show you how actually it goes and identifies HSIL, LSILs, and all the infections and actinomyces and etc. So next slide, please. Yeah, here it is analyzing. Okay, once it analyzes, it uses the same thing. First, it goes and sees whether there is adequacy. Bethesda tells us to look at adequacy first and all other things later. So first thing that it will tell you is about adequacy of the smear. Are there enough cells on it? Is there adequate material on it? And once it passes through that, it actually starts functioning on looking at the slides. This actually replicates the thought process of a human brain or a cytotechnologist or a cytopathologist. Now, when you actually start analyzing it, the whole thing has a background of the latest Bethesda classification, and it puts these cells and all these structures into a Bethesda classification, and then it draws conclusion. In this picture, you can see that it is showing, it's highlighting few cells. Okay, so it puts these cells in a tray and starts displaying in front of you with its own brain. And then you can, of course, override that, but you can also depend fairly well on the solution because it is really very effective and has been validated and has received a lot of acclaim from a lot of people. So now this is how it functions. See, now if you can see on the left side, you have cell number 9 and 10. There's a small little bracket which has gone around it, and each of the cell is displayed in the tray to look at it intensely, closely, and think about it. Next. So this as I was telling you, the cytology solution has other features also. It finds parasites, it finds candida, it finds actinomyces, it finds HSIL, squamous cell carcinoma, all those things, all the cells and all those features of classification within the Bethesda are all displayed in those trays, and a complete Bethesda classification is offered. As we have been building all these things and bringing them to the table, we have received a lot of appreciation from different parts of the world, and I would proudly like to share it with you people before I stop my talk and end my discussion. We have some people saying that our system is very encouraging, while at the same time, they're saying that the feedback from whoever they showed these scans to have said that it's an incredible solution. Next. And we have people saying that the affordability is the highlight here. Actually, that is what probably, like Abhi said, the affordability is the thing that would stop me from actually touching and reaching the scanners. But here we have an option now. And this whole thing comes in a complete digital pathology package, right from picking up the slide to coming out with a result. Can you go back, please? Yeah. So we have a couple of other people also close to us and who are actually using it for multiple purposes. There is this person who says that the load is very high. You know, in those situations, the whole expectation from a scanner and the whole system is completely different. If you have a huge load, that is where everybody should have a scanner. If you are in a teaching institute, that is where you should have a scanner. If you are actually very keen on having better quality of resolution, if you want to make good presentations out of it, if you want a good after-sales service, these are the people who have said so. So this is what probably a scanner should bring to my table as my requirement: after-sales service, volume, and crisp images. if that is what you get, why would you not stop from buying a scanner which is affordable? Okay, next. Yeah, and this is the thing that we wanted to share. We have 4 partners, we have 5 US patents, we have 8 US trademarks, we have all over the world distributors, we have global installations more than 50, we have huge slide image data, and a lot of annotations. And we are adding to it every minute. Next. Next. Thank you. If there are any questions, I would like to take that.
Thank you, Abhi and Dr. Aparna, for this lovely presentation. Now, we would like to answer all your questions, any doubts, how to implement digital pathology, what are the next steps. Please share your questions in the chat, and we are up for taking that up. So, Abhi, there's a question where one of the participants would like to understand, before they choose any digital pathology provider, what are the key aspects, or what are the key aspects they need to consider before implementing digital pathology?
So I would say, firstly, how are they managing the labs as of today? How many slides load that they are looking to digitize? There is a possibility that some pathologists may be using these tools for only some specific segment of their workflow. In certain cases, they really would like to know, like, why are they planning to go for digital pathology? So one of the reasons why people go for digital pathology is the need of telepathology, where they would like to share the data, or they themselves would like to look at the slides remotely because they now cannot physically go to their own hospitals. So telepathology is certainly one such driving factor for adoption of digital pathology. The second factor is, like where you have lots of slides that you are storing for years and years as a part of the regulations. And you really do not want those slides to occupy your real estate. Rather, you would like to digitize those and move these physical slides to some remote location. And then the third reason for digital pathology adoption is in terms of using the computer-aided diagnostic tools to make your diagnosis and research more accurate. And that is where, depending on what priorities you are looking at, depending on what kind of workload that you are talking about, I think the choice of digital pathology should be made. Now, once that is made, like, for example, OptraSCAN offers on-demand digital pathology, where you don't need to be worried about buying the systems. You can just start using the systems in your laboratory, and you pay only based on the number of slides that you scan, number of slides that you store, number of slides that you analyze. So this is more like a subscription model, where it's very easy for many laboratories to adopt to this digital pathology because there is no upfront cost. I mean, there is no cost that you have to pay on the day one. But as you use it, as you consume it, you pay for it. And that's where I think your budgets, your plan of action also play important role.
Thank you. The next question we have is, what is the best price for the instrument? And I think you can take this up. You can answer these two together. And the second question is, what is the resolution of the scanners?
Yeah, so maybe I can take the second question first. So in terms of the scanner resolutions, the scanner is able to scan the slides using an optics, which produces an image equivalent of 40x of microscope. And again, what happens is that this is a scanner, this is a digital scanner. This is different than the optics of a microscope, because in the scanner, you have an optics, but on the top of it, you also have a camera. So there is also an optics within camera. So the combination of this essentially talks about an equivalence, and that's where I'm referring as an equivalent of 40x, which is 75,000 pixels per inch, which is equivalent to quarter micron per pixel at 40x, or half a micron per pixel at 20x. And that's kind of a resolution of the images that we generate here. Each of the image in an uncompressed format is almost a gigabyte of a data. We provide images in the format of JPEG 2000, TIFF file format, and our images are open file format, so that unlike some other companies where their images are proprietary, we believe in the open image formats, because then we would like more and more people to share those images, analyze those images, and eventually it should be beneficial for the whole community. Recently, we have also started interfacing with DICOM. So all these images are also now available in a DICOM format, so it can go and sit into any of your PACS systems as well. And then coming back to the first question about the pricing. So these scanners are, there are various types of scanners, like our first product OS 15, which is for the 15 slide scanning device. That costs around 25 lakhs rupees. And then this varies from the workload that you have in place, right from the 15 slide scanning to 80 slide scanning to 160 slides to 320 slide scanning to 480 slide scanning. So it has a complete wide range of the scanners to choose from. And then you can always make the combination. But at the same point of time, we also have an option for you to buy this scanner on a lease basis, where you don't need to invest in purchasing the scanners, but you pay only as a digital lab as a service, where you tell us your laboratory and our people will install the scanners at your place. And then based on the workload, based on the number of slides that you are scanning and analyzing, this is more like the pay as you go or the scanner as a service.
Thank you. The other question is, what's the configuration of the device for analysis?
So for analysis, we have various analytical tools. Some of the tools that helps in quantifying the biomarker protein expressions using immunohistochemistry. We also have the tools for the morphological analysis. And then for using these tools, we have it based on the tissue morphology. So you can choose for the breast panel, you can choose for the prostate panel. We also have for the lungs, we also have for the brain and renal panel. So based on the various types of tissues that you are working on, you can choose what kind of analytics that you are looking for. And then again, in terms of the immunohistochemistry versus hematuxin eosin, or maybe based on the morphology. So you can choose the primary or the secondary. And then based on that, you can actually configure what you're looking for. We have also completed the clinical validation of the system for the cervical screening programs. And that is where for TinPrep, as well as the cytosmears, we have a product called as a cytosia that essentially analyzes all the cytological samples for its adequacy, as well as identifying the abnormal cells, as Dr. Aparna was explaining, and then displaying those for the review and the verification by the cytopathologist.
So the other question is quite interesting, considering our participants today are from various geographies, right from Asia, Middle East to Europe. During these times of COVID, installation of scanners and sending engineers becomes quite a task. So the other question, basically, they want to know, how would you go about installing the scanners and the remote support?
Yeah, so we have 24/7 support and services from our both offices. We have one operations in California, and we have another operation here in India for the customer support. And our scanners are all IoT enabled. So once the scanners are up and running, all the health of the scanner is logged, and that is where we do preventive maintenance. And all the scanning solutions are managed remotely. At the same point of time, if there are any issues with the scanner that requires attention for the physical visit, we have our distributors who are trained to handle those scanning, troubleshooting approaches. But at the same point of time, there are some situations where the scanner requires some component replacement. So at that time, we actually replace the scanner by sending another scanner, by bringing back your scanner, and then overhauling that, and then sending it back to you guys. So this scanner is very easy to install. I mean, it is like your printer concept. So you don't require the installation team. You don't require the engineers to visit your site. We ship the scanner. You take it out of the box. You start power it on, and it starts operations. And it's very easy. It has its own configuration. It has its own benchmarking. And then we also offer the remote training, installation, and any troubleshooting that is required.
Thank you. The other question is, How does it handle staining and quality of sections?
Yeah, this is a good question. And I thank you, Ashok Kumar, for this question, because this is ultimately, at the end of the day, this is a machine, and not as a magic. This has some dependencies on the staining patterns, but at the same point of time, this is also a function of our quality assessment tool. So what we do is that whenever we do the scanning, our system is able to automatically quantify the quality of an image, and based on that, it will highlight to the user whether the slide is scanned properly and the image is available in a proper format with a good quality, or if there are any issues, it will indicate to the operator saying that this slide may be required to rescan. And that is where, when you have 15 slides loading, you yourself can look at it. But when you are using our scanners with a high throughput, where you are looking at 100 to 300 to 400 slides scanning, it is impossible for a human being to manually verify the quality. And that's where our automated tool for verifying the quality of each of an image comes into very handy. So we actually will highlight to you, like maybe slide number 72 and maybe the slide number 195 is something that you need to rescan. So for our walkaway automation, such quality assessment tool plays an important role to ensure the good quality, because we offer 99.99% of the regions are in focus when we generate an image. OptraSCAN actually ensures that all the slides are converted into digital images of very high quality. So the varying patterns of staining, as well as various sections thicknesses, and I assume quality of sections means section thickness that you're talking about, are handled very well into the system, but with the help of the smart software that is integrated as a part of our complete solution. So I also see one question, in terms of, I think Sujit Joshi has asked this question, how much storage to have is a big question mark. Absolutely. But then it all depends on, using your storage, which is a cloud storage. And that is where we do provide cloud storage, and each of the slide gets converted into digital image. And assuming that you are scanning at equivalent of 40x, then this digital image in a JPEG 2000 format will be around half a gigabyte of a data, or 500 megabyte of a data. Now you are talking about one slide with 500 megabyte of a data, and then you are going to be storing lots and lots of slides. So you do local storage or you do cloud storage. We do provide 1 terabyte, 5 terabyte, 25 terabyte, and even to the petabyte of a data storage. So we do provide those storage options. And once you take our solution as a digital lab as a service, then you don't need to be worried about the storage aspect, because you guys are pathologists and you should not be worried about the information technology and then infrastructure challenges. And that's where we offer the scanners, we offer the workflow software, we offer the analytics, we offer the storage, we offer the telepathology as a completely managed solution. So where you will be paying for that solution only when you use it, only for the number of cases you use it. And that's where it becomes also economical for you. Also, you can justify your return of investment, because if you have the case, it means you have the patient, and it means you have got the revenues for that. And that's where you can justify all of this cost. The whole philosophy of OptraSCAN relies heavily on the fact that digital microscopy has to be affordable. We cannot think of a microscope transformation into digital infrastructure on the same lines like your X-ray machine getting transformed into CT scan. No, because the economics there are different. In case of pathological laboratories, the economics are entirely different. The economics are based on low volume and low cost approaches, and that's exactly where we have a solution where some of our customers are also using it for on a pay-per-use basis, where that cost is as low as 50 rupees per slide, where you get everything in just 50 rupees. You're not even paying for the scanner, you're not even paying for the storage, you're not even paying for the analytics, because it's all got together. Again, it all depends on the number of slides, and it all depends on the workload that you have. But then again, this is one of the options that I would like all of you to consider, because this has been of great help to many of our customers. And I'm sure some of you, if you have an interest, you can reach out to us and we'll be happy to show it to you. We'll be happy to discuss with you and see how best this can be made as a part of your day-to-day routine at your pathological laboratory.
So the other question is, what do you mean by continuous loading?
So by continuous loading means, you can load the slides and you can start the scanner and you can walk away. But that's something where if you want to add some more slides, you have to really wait for all the slides to be completed. That was one of the limitations that we've observed in the market. And that's why our system is a continuous loading, where you can even open the scanner and the loading of the additional slides is possible without pausing the scanner. So at any point of time when the slide is getting scanned, you have remaining loaders available to add more and more slides. And that's where you do not require to pause the scanner. So that is where whatever the slides that are completed, their scans are completed within the system, those can be removed and you can add the new slides. And that's where you can keep on adding more and more slides into that, and scanner continues operational 24/7, to scan your slides into high quality images.
Thank you, Abhi. Thank you for taking all those questions. Thank you, Dr. Joshi, again for helping us with this presentation. We would also like to thank all the attendees who attended our webinar today. We are available to answer all your questions, be it anything in terms of digital pathology. You can email us at info@optrascan.com. Be it any questions, be it any concerns, our team will be here to take that up. Before we say goodbye, we have last question and we'll take that up. That is, what is the average uptime of these scanners? And that's by Akshara Jogi.
Yeah, so Akshara, the uptime of the scanner is something that we ensure, which is 99.9%. And how we do that is through the preventive approaches. Every day you start the scanner, the health of the scanner information is logged into the system, and our support team comes to know immediately any of the parameters that are going off. And that's why our scanners are all called as IoT enabled. And because of that, we can remotely log in and fix those issues immediately. At the same point of time, if you have more workload, then we do provide something called as a shadow scanner. So you may be taking only 2 scanners, but actually there are 3 scanners sitting there. And then the shadow scanner ensures as a redundant scanner to take care of your laboratory requirement. So we have those model called as a digital lab as a service that gives you almost 99.9% of the uptime. But if you are planning to buy a single scanner, even that scanner is possible to be managed remotely because of the complete technology infrastructure that we have that keeps the track of how many slide data scan for after how long the scanner performance is deteriorating. And then based on that, we have those predictive values, which ensures the uptime of the scanner to make sure that all your slide load is handled to the fullest extent as defined while designing the systems for your laboratories. So I think that's pretty much about it, and I really appreciate all your time. And I thank you, my medical director, Dr. Aparna Joshi, and my marketing lead, Anjana, to facilitate it. And I wish you all the best. And if there is anything we can be of any help to you, do reach out to us, and we'll be happy to show you what we have. Have you talk to our customers to get their experience. At the same point of time, have you try your own data using our systems. So thank you so much, and have a good evening. Bye-bye.
Thank you.